This is the second lesson covering solving by factoring for Pre-Calc 11. So if you haven't already done a lesson on the first part of solving by factoring, make sure you go back and check that out, or else you're going to be a little bit lost. In this lesson, I'm not really going to be going over anything new on a grand scale. It's more going to be how to deal with specific situations that can come up when you're solving by factoring, things that can be a little bit different than your standard question. So going straight into it. If you had to solve something like, let's say, x squared plus 10x plus 25 equals 0. Pretty innocuous looking, right? It's a pretty standard looking quadratic. We're solving by factoring, remember, so our first thing we're going to want to do is, of course, factor this. And so multiplying to 25, adding to 10, that's actually going to be 5 and 5. So when we factor this, we get x plus 5 times x plus 5 equals 0. And so what should probably stand out about this one to you is that those are the same thing. And so what we get from this is that x is negative 5 or negative 5, but that's just the same answer. So this is how you end up with only one solution. So you might remember when you were first learning about quadratic equations that they can have 0, 1, or 2 solutions. So of the first video, everything I covered had 2 solutions, because that is often what you're going to deal with. This is how you end up with one solution. It's when you have a repeated factor. This would be a perfect square polynomial. Next up, you can probably guess what might be coming. Would be something like this. X squared plus 5x minus 3 equals 0. And so you look at this, you want to find two things that multiply to negative 3 but add to positive 5. Well, multiplying to negative 3, that's just going to be either 1 times negative 3 or negative 1 times positive 3. Neither of those is going to get you 5. Your first instinct might be to say that then this has no solutions, but that's not actually necessarily true. This one does in fact have 2 solutions, but there's no way for you to be able to find them by factoring. So this one isn't factorable. That is definitely true. But we still can't say for sure whether it has 0, 1, or 2 solutions, so what we have to do is solve it a different way. Whatever that way might be. All right, so that could be the graphing that you might have already learned, or that could be the other 2 methods that I'm going to cover later in the unit. Okay, so that's what 0 solutions, or not even 0 solutions, that's what ambiguous number of solutions and one solution look like. So let's get into some specific kind of equations you might have to deal with. So first up, x squared minus 64 equals 0. So from the factoring review that you should have already done, you should hopefully recognize this as a specific kind of polynomial, which is a difference of squares. And these things are really easy to factor. So x squared minus 64, remember we're just going to look for square roots. So the x squared is just going to get me an x. 64 is going to get me an 8. So this is x plus 8 and x minus 8. And so if you solve those, we end up with x equals negative 8 or x equals positive 8, right? It's one or the other. We can write that a little bit more succinctly by saying x equals this. So an 8 with a plus and a minus sign in front of it. And so that little symbol really just means plus or minus. So it means positive or negative. So this is our way of saying x can be positive 8 or negative 8 without having to write out both of the 8s. And that'll be true for any difference of squares. So for example, try solving 16x squared minus 121 equals 0. So pause here for a second, give this one a shot, and see how you do. All right, so if we factor this, 16x squared is going to get me 4x, 121 is going to get me 11, and so this is 4x plus 11 times 4x minus 11 equals 0. So if I break one of those up, it doesn't really matter which one, say the plus. So we've got 4x plus 11 equals 0. I want to solve that, so I'm going to subtract 11 on both sides, which is going to get me 4x equals negative 11. I'm going to divide by 4. Which is going to get me that x is negative 11 over 4. And so I could go through and do that all over again with the other factor, but I know it's going to get me the same things because I'm still just going to be moving an 11 and dividing by 4. So my solutions are just x equals plus or minus 11 over 4. Great. Next up. So say I wanted to solve this. X squared minus 5x minus 67 equals 17. And so looking at this, something should hopefully stand out to you. At first glance, this one is completely different from every other one that I've done in this video and the previous video in one key way. And that is not in the quadratic, but it's actually what's in the other side of the equation. So for all of the other ones, our equation always equaled to 0. This one doesn't. And here's the thing. It has to equal to 0. Because if it doesn't, that whole logic of multiplying two things and getting 0 means that one of the things has to be 0 completely falls apart. There's infinitely many ways to multiply something and get 17. It's not a nice number, but you can still make it work. So the long and short of this is to solve, the equation has to equal 0. But that doesn't mean we're lost. We can still do something with this. And so it must be equal specifically to 0. Okay, so what we can do, though, we don't have to give up, is we can just make it equal to 0, but not by just getting rid of the 17. Instead, what we're going to do is we're going to move that 17 over to be with everything else. So we're going to move all of your terms to one side of the equation. Which side is up to you? Usually there will be one side that is a better choice than the other. So what I'll typically do is try to make sure I get positive x squares. So in this case, since the x squared is already positive, I don't want to move it. I want it to stay where it is. So we're not going to move everything to the right side. We're just going to move that 17 to the left, which is going to be pretty easy to do. So we've got x squared minus 5x minus 67 equals 17. So to get rid of a positive 17, we're just going to do a negative 17. Remember, when you're moving a term from one side of the equation to the other, it's always going to be adding or subtracting. It's only when you're moving part of a term, like a coefficient, that's when you'd multiply or divide. So in this case, it's definitely subtraction that we want, which is going to get me x squared minus 5x minus 84 equals 0. Being careful with your integers, please. So what multiplies to negative 84 and adds to negative 5? That is going to be positive 7 and negative 12. And now this one is really just like any other question, right? It's just a quadratic that equals to 0. You do your usual thing. You factor, and you solve both of those. So that's going to get us x is negative 7 and x is positive 12. Done. And so anytime you've got 0, or so you don't have 0 on the other side, make sure you do that first. And that doesn't just apply to solving by factoring. That really applies to any of our solving methods. All right, throw in another wrench into the mix. Let's say I ask you to solve this, x squared over 4 plus 7 over 4x plus 5 over 2. You absolutely could try to handle this as is, but I wouldn't recommend it. Dealing with fractions when you're factoring is typically not a great time. So our goal to make this a little bit easier to deal with is going to be to get rid of the fractions. So you might ask yourself, well, how am I going to do that? How do I get rid of these fractions? I can't just make them disappear. Thankfully, it's pretty easy to deal with. All we have to do is we're going to multiply. But specifically, we have to multiply all of the terms, not just one of the terms. So even if there was only one fraction here, we do still have to change all of our terms. And we're going to multiply by a common denominator. It doesn't technically have to be the lowest common denominator, but it's always going to be easier if it is. So looking at our terms here, our denominators are 2 and 4. So our common denominator is actually just going to be 4. And so what we're going to do then is we're going to take all of our terms. So x squared over 4, we're going to multiply that by 4. And then 7 over 4x, we're going to multiply that by 4. And then 5 over 2, and you guessed it, you can multiply that by 4 as well. Keeping in mind that to make this a little bit easier, you might want to write this as 4 over 1 instead. And so now we just got to get rid of these fractions by simplifying. So for the first two terms, the 4's are actually just going to cancel out. We're multiplying by 4 and dividing by 4, so that's all just gone. For the last term, since our denominator is 2 instead of 4, we're going to have to do a little bit more work. If you simplify that by dividing both the terms by 2, you're going to end up with a 1 and a 2. So now, if we clean this all up, my first term is now just an x squared. It's x squared over 1, but the 1's not doing much. My second term is now just a 7x. And my third term, if we do the 2 times the 5 that we've got up top, is going to be 10. I got a little bit lazy here. I forgot the right side of my equation. We do also have to multiply the 4 by 0, right? You've got to multiply everything. You can't just do one side of the equation. But since the right side of the equation is just 0, 4 times 0 is still just going to be 0. All right, and now this is something we can factor and solve pretty easily. X squared plus 7x plus 10, multiplying to 10, adding to 7 is just going to be a 5 and a 2. So we end up with x is either negative 5 or negative 2. Okay. Trying an application question now. So let's say we've got a rectangular room. And that room has an area of 40 square meters. And I can give you a little bit more info about this. So if one dimension of the room is 3 meters longer than the other. So dimensions, remember, is just length and width. So one of those is 3 meters more than the other. What are those dimensions? And you might be able to just look at this and say, okay, well, since it's 40 and then that 3, you can kind of logic your way through it, but do make sure you understand how to actually solve this properly. So let's think our rectangle. You might notice from me or from your other classes, math teachers love working with area because it is an easy way to set up questions involving multiplication. So it's something you do have to kind of get used to. So we know this is 40 square meters. We also should hopefully know that the formula for the area of a rectangle is length times width. We know that that area is 40. That's just given to us. This is 40. We have to find some way to work with that bit about one dimension being 3 meters more than the other. So think about what that means to be 3 more. If you have $10 and your best friend has $3 more than you, how much money do they have? It's not going to be 30, right? That's 3 times more. It's just going to be 13, right? It's 3 more. So 13 is 3 more than 10. And so if we want to characterize that in terms of variables, we didn't specify, so you can kind of pick length or width here, but I might say something along the lines of the length is 3 meters more than the width. So it's the width plus 3. And so what we're going to do is we're going to take this thing, this w plus 3, and we're going to shove it into our formula there. This might seem kind of familiar to you if you remember the stuff from chapter 3 where you were trying to maximize the area inside of a fence. We're using some similar processes here. It's not exactly the same. We're not going to be finding a vertex or anything, but similar ideas. So if we put this all together, our area is 40. Our length, we're going to say, is w plus 3. And then our width is just w. And so here's our equation we need to solve. So the first thing we're going to do probably is get rid of those brackets by distributing the w. And so we've got 40 equals w squared plus 3w. And so this is quadratic. We want to solve it by factoring, graphing, whatever it happens to be. In this case, we are factoring. Thinking back a couple examples, remember I said you have to have one side being 0. So that 40 is in the wrong spot. You could move everything to the left, but that's going to get you a negative w squared, and it also just means more work. So the better bet here is to subtract 40 on both sides to get everything over onto the right, which is going to get you 0 equals w squared plus 3w minus 40. All right, so we're going to factor that. That's going to be w plus 8 and w minus 5. And that's going to get you w equals negative 8, or w equals 5. So your width is either -8 or +5. And then you got to think to yourself, well, does it make much sense for a room to be -8 meters wide? Probably not. So we're going to have to reject that answer as just being not physically possible. So great, our width is 5 meters. That doesn't fully answer the question though, because remember the question asked us for the dimensions. So we have one of the dimensions, but the other one, our length, we got to figure out still. Thankfully, it's pretty easy. We already wrote ourselves a nice little equation for it when we said that the length was the width plus 3. So if we put that together, length is w plus 3, but the width is just 5, which tells us that our length is 8 meters. And there we go. And if we think that does match with what we've got, one of those is 3 more than the other, and if we multiplied them, we would get 40, so we're great. Okay, the last thing that we're going to look at is a couple of harder types of questions. This is something pretty advanced, but something that you do want to know how to deal with. It's a skill that you might use in other classes as well. So if I want to solve x plus 2 squared plus 11 times x plus 2 plus 28 equals 0. And so this looks pretty gross. There are 2 different things you could do with this. So your first instinct, and the only thing you could kind of do with what you know right now, would be to just multiply everything out, right? So you would FOIL out the x plus 2 squared, you would distribute that 11 through, you'd combine some like terms, and then that would absolutely work and it'll get you an answer in this case. For more complex ones, though, that's not going to be a useful strategy. So what we're going to do instead is I'm going to introduce something new to you. We're going to use what we call a dummy variable, which might sound like a not very nice thing to call something, but what a dummy variable means is it is a variable, and a dummy is like a stand-in for something else. And so a dummy variable is just a variable that is going to temporarily stand in for something. In this case, it's going to stand in for those x plus 2s that we don't really like. So it's sort of like a temporary fake variable. We're not going to have it in our answer. It's just going to be something that we're going to use while we're solving to make things look a little bit easier. And so dummy variables are typically used in cases where you have something that's repeated in a question. So in this case, it's those x plus 2s. Not always, but that's usually what they're for. So the way you do that is you'd say something along the lines of let a equals x plus 2. So this is what we'd call a let statement. I'm defining something for other people. And so what we're going to do now is we're going to replace the x plus 2s in the question with a. And it doesn't have to be a. You can use any variable you want. You can use a symbol if it makes your life happy. Just something. So if we go back to our quadratic now, so we had x plus 2 squared plus 11 times x plus 2 plus 28. So if we swap out those x plus 2s, now it looks like a squared plus 11a plus 28 equals 0. And that looks much nicer all of a sudden. So we can factor this just normally. So multiplying 28, adding to 11, that's going to be x plus 4. Oh, sorry, it's not x, right? Remember, we swapped out the x. It's going to be a plus 4 and a plus 7 equals 0. And so now that we've managed to do the factoring, we're going to go back and we're going to swap out those a's for the x plus 2s. And so now we'll have x plus 2 plus 4 and x plus 2 plus 7. Right, so these two a's got replaced with those x plus 2s. And now this is something we can work with. So we can simplify a little bit, right? So x plus 2 plus 4, I'm just going to add those like terms, and it's going to get me x plus 6. X plus 2 plus 7, I'm going to add those like terms, and it's going to get me x plus 9. And then this we can finish off. So looking at this, we end up with our two solutions, x equals -6 or x equals -9. So I'm going to give you one more of these to try on your own. It's going to be a little bit more complicated. It's going to have some extra steps to it, but the process is going to be pretty similar. So I would like you to solve x squared plus 6x squared plus 13 times x squared plus 6x plus 40 equals 0. So if you look at this, if you were to square out those that first set of brackets, you'd end up with an x to the power of 4, which again, you're going to have no idea how to handle. So go ahead, pause here, and see what you can make of this one. I'll tell you right now, you're going to end up with lots of solutions. All right, so let's write ourselves a let statement. And let's just keep it pretty simple. We'll say let a b. So you can use the word b or you can use equals. I'm typically going to use an equal sign. So let a equal x squared plus 6x. So if we make that switch, we end up with a squared plus 13a plus 40, which, again, pretty easy to factor. So multiplying to 40, adding to 13 is just going to be a plus 8 and a plus 5. And now we make the swap back. So these a's are getting swapped back out for x squared plus 6x's. But as you can probably guess, that's going to be a little bit more complicated than it was last time because we're going to have squares. And so we're going to have x squared plus 6x plus 8 and x squared plus 6x plus 5. And that's going to equal 0, just like the last few terms. And so now we want to solve these. So we basically can split these into two separate equations. So we've got x squared plus 6x plus 8 equals 0, and x squared plus 6x plus 5 equals 0. But these are quadratic, and so we've got to go through the whole process again by factoring these two things now. Thankfully, they're pretty easy to factor. So the first one is going to factor to x plus 4 times x plus 2. The second one is going to factor to x plus 5 times x plus 1. And so we end up actually with 4 different solutions here. Each of these factors gives you something. So we've got x can be either -4, -2, -5, or -1. And there we are. So that is solving by factoring. Next up after this, you're going to learn a third method of solving using something else that you covered in Chapter 3. But you'll have to watch that video to find out.